In the last video, we talked about probability sampling. Suppose you have a target population of people who you'd like to study. You create a list of those people who are known as your sampling frame. You then sample from that list. In a simple random sample, you might draw 10% of the people at random. Then you get a sample, the people who sampled, and the people who responded to your sample. And there are various sources of error that we discussed in the last class along the way. As our example, we talked about estimating the proportion of our class who prefers to sit in the front of the classroom. Today we're going to turn to a related question, subgroup estimates. Do the people in the first 3 rows prefer the front? If we wanted to answer this question with a probability sample, we might have to think carefully about it. The way we did it in the last video was a simple random sample. Everyone in the class ran the command runif to draw a random number between 0 and 1. Then those whose number was less than 0.1 responded. Today we'll talk about another way to draw the sample. This is an unequal probability sample. We're going to have everyone run runif. Then for the people who are actually sitting in the first 3 rows, we're going to have them respond if their random number is less than 0.5. For everyone else, we'll have them respond if their random number is less than 0.1. By drawing the sample this way, we created a sample that looks like the sample on the right. We have a smattering of people in the back of the room, about 10% of them responding to our sample. And we have quite a few more people in the front of the room. Half the people in the first 3 rows are responding to our sample. On the left, we have our sample design. The people in the back have a known probability of sample inclusion, 10%, and the people in the front have a known probability of sample inclusion, 50%. When we think about analyzing this unequal probability sample, we have some advantages when it comes to estimating this subgroup estimate. After all, the particular sample we draw may differ across random draws of this sample from the population. But no matter how we draw it, we know we're going to have a pretty decent sized sample of people sitting in the front of the room, because we've designed the sample that way. The unequal probability sample gives us better power here for answering questions about the proportion who prefer the front of the room among those sitting in the front of the room. So we've now talked about 3 ways to draw a sample. Full count enumeration is talking to everyone. Then you get the answer in the population and the answer in all the subgroups. You have no uncertainty. This is really ideal but also quite costly. We then talked about simple random sampling, where every person is sampled with known equal probabilities. This is good for population averages. And finally, we talked about unequal probability sampling. This is when every person in the sampling frame is sampled with known probabilities, but those probabilities are different for each person in the population. This is something we might do if we want to know a subgroup estimate, like the proportion with a particular preference among those sitting in the front of the room.